The second physical data independence example is optimizing the data storage. For example, uncompressed files to compressed files, or applying the partitioning or some other optimization techniques applying. So the third example is changing the storage devices from HDD to high ultra speed solid state device. So for example, if we change underlying devices, so this won't make any impact on the logical level or view level. Okay, another example is changing the index type. For example, we can change the index type from the sequential scan to P3 index. So this is the another change we can make at the physical level. So this is the another example of physical data independence example. Store data in different locations, for example different racks, etc. So any type of physical level changes won't create any impact on the logical level or view level. So this is the example of the physical data independence. Okay, who uses the physical data independence? So mostly it is the DBAs, system administrators, DBMS developers. Okay, the second is the logical data independence. Okay, its definition is ability to change the logical schema without affecting the user view or application programs. So this is the real diagrams. For example, here is the application and the user view. So below that there is the logical changes here in the second part. So as you know, there is a schema on the logical level, tables, attributes and the constraints, relationships, etc. So we can make any changes in the logical level. So we will see the different examples of logical data independence examples. For example, we can add the new column in the schema. For example, we have the student table and its column is the ID and name. So before that we have the query select ID and name from students. Okay, this is the query which fetch some data and present the view to the user. If we make any changes in this students table and add the email ID, email as well, name and email. So we are adding the new field email here. So this query still works and it don't impact the programs or user view. So this is the one example, adding the new column in the schema. We can split the table. For example, we have the sum table, for example, which had the ID and name and the department. So okay, we can make the correction in our database. So we can create the, okay, this is the students table. We can create the two tables from here. One is the students table ID and the name, and then we can create the departments table. ID and the department name. So this is the splitting of one table into two. One is this and the second one is this. So we have split the one table into the two, students and the departments. So this is the logical schema change. So it won't impact the view level. So this is the logical data independence example, adding the relationships. So in this way, in the same way, we can add the more relationships between the, for example, we can add in the student table ID, then name, and the department ID. So this is the foreign key. We will discuss the foreign keys in later videos in detail, but I am here showing you we can make any relationship between the two tables. It represents the departments table. For example, this is the department table. So this is the ID and this is the department. So this is the, here it is the primary key and here it is the foreign key. So in this way we can create the relationship. So this is also logical schema changes. So this is the one of another example of the logical schema changes. So because of the logical data independence, so it upper level view level it's don't change. Why logical data independence is harder? Because the changes impact the tables, columns, relationships. Therefore the logical data independence is harder to achieve rather than the physical data independence. So here is the comparison table. Okay, so feature these changes at and physical level or logical level, affect the storage details, and logical level data independence changes impact the tables and relationships attributes. Impact on the application, physical level changes are none impact, and logical data changes are impact minimal. The change in the logical schema requires a change, sometimes change in the application level as well. So it has some impact as well. Difficulty, physical data independence is easier and logical data independence is harder. Data is mainly dependent on the logical structure of the data. So example, as I mentioned, the physical data independence is adding the index and logical data independence is adding column as we have seen before. Okay, relationship between the data abstraction and data independence. So as you see, there are three levels: view level, logical level, physical level, as we have discussed in the previous video. So because each level are separated, physical level changes don't impact the logical level. If we change here, it don't impact the upper level, logical level and view level. And if we change the logical level changes, it is minimally impact the view level changes here. Therefore the data independence is achieved because of data abstraction. So this is the biggest benefit of data abstraction. Okay, here is the real world example, YouTube example. You can see, for example, before that upgrade, it is using the LTT drives in the data centers. So undergone upgrade and it is replaced by the SSD storage, and the compression techniques are applied, in index optimizations are applied. So this is the physical data independence. After the upgrades seamless change, user view the YouTube videos seamlessly. It is a normal way as before the changes. So user don't can guess there is some changes or not. So this is the example of physical data independence. So in the right side there is the example of logical data independence. So for example, user in the YouTube want to add the playlist and shorts, etc. So for this YouTube has to modify the schema and add the table to store the playlist data and shorts data. So this is the change in the logical layer. So it won't impact or minimal impact the user view, right? So this is the example of logical data independence. Existing user view and application remain unaffected. Okay, why data independence is very important? So it is very due to the following reasons. It is easy maintenance. So as we have seen, so we have updated the underlying storage or underlying schema, so without changes the code. So better performance. We can optimize the index optimization and get the better performance. Scalability. We can scale the databases as well, so and achieve scalability. Reduce development costs, so there is no code changes or application level changes. So only hardware or schemas level we can evolve the independently. So this is the easier upgrade due to the data independence. Flexibility in database design. So we have seen we can make the database design changes and add the new features, new tables, new columns, split the database tables. So due to the logical data independence, we will get the flexibility in database design as well. Consistent user experience. So user experience remains consistent in spite of we are changing the underlying storage, compression techniques, partition techniques, or even logical schemas, etc. So user experience remains consistent, or we may experience a very minimal change due to the schema level changes. Key takeaways: data independence means changes in one level should not heavily impact the higher levels. There are two types of databases: physical data independence and logical data independence. Physical data independence is easier to achieve. Logical data independence is harder because it involves schema changes, as we have seen before. Data independence is one of the biggest advantages provided by the data abstraction. So this is the data independence. We have seen in a deep how data independence we can achieve and what are the biggest advantages of data independence. So in the next video we will discuss the database architecture, 1 tier, 2 tier, or the 3 tier architecture. So until next time, bye bye.